Okay, for topic two, we're going to talk about the angle side case. You'll see this one, angle side. Okay. This is one of the not weird cases. So we've got that weird ambiguous case. We'll cover it last. So we'll do the two easy ones first. Let me actually get rid of that screen. Let's go here. Okay. So let's talk about this. Example one says draw each triangle and then solve. So let's draw the triangle. Let's make sure we understand the angle side situation. Okay. I generally label my triangles kind of the same way, and I never draw them to scale, so please understand that. So you may get angles that don't like match the size, but I always draw my triangles the same. I start like this, and I always go A, B, C, okay? And then remember, opposite of big A is little a, opposite of big B is little b, opposite of big C is little c, okay? And let's fill in what we know, okay? So we know angle A is 20 degrees, we know angle B is 80 degrees, and we know side length A is 4. Now, what's nice about this particular case is you have two angles. And if you have two angles, you can easily find the third because remember, the three angles of a triangle have to have a sum of, hopefully at home you're screaming 180 degrees, okay? So it's not going to take a lot of work for us to find angle C. So let's go ahead and do that first. Let's do the easy part first, okay? So C is going to equal, well, we can't just assume one of these angles is 90 degrees like we were able to do last time. So we really do have to take 180 degrees and subtract what's already been used. We already have one angle that's 80 degrees, another that is 20 degrees. Well, 80 plus 20 ends up being 100. So if I take 100 away from 180, I get 80. So we have here that angle C is now 80 degrees. Because we have two angles that are the same, this is actually an isosceles. I just spelled that wrong. This is an isosceles triangle. I have no idea if I spelled that right. That looks so stupid. If it's not, who cares? I am a mathematician, not an English major. I do not have to spell correctly. Okay. So we have an isosceles triangle right here. So we know if we have two angles that are the same, we're going to have two sides that are the same. So if angle B has a length of B and an angle of 80 degrees, and angle C has the same measure as B, that tells me that B is going to equal little c. Okay, so we're not going to have to do quite as much work here because we have an isosceles triangle. Okay, so this is all well and good. We have all of the angles, but we don't have enough of the sides. We only have one side, and we cannot use the Pythagorean theorem. This is not a right triangle, so you got to let all that right triangle stuff go. So what I generally do is I write out the full law of sines with all of the information I have so I can see what I have and what I don't have. So sine of A is sine of 20 degrees, and big A goes with little a, so that's sine of 20 over 4. And that is equal to sine of B, which we know is 80 degrees, over little b, which we don't know. And that has to equal sine of C, which is also 80 degrees, over little c. So we're missing two pieces of information, but the good news here is we have one entire ratio. We know sine of 20 over 4. So what we can do is we can take each of these pieces for B and C, and you have to do them separately. Remember, you cannot solve three ratios all at once. You can only do two at a time. So what we can do is we can take the information for angle A and side A and set it equal to the information for angle B and side B. That's going to be some proportion. We know these are true. So let's go ahead and just do that and solve. Okay, so kind of off to the side, I'm going to say, okay, I have sine of 20 degrees over 4 is equal to sine of 80 degrees over B. Okay, now what? Okay, so you got to go back to your beginning days of algebra, and we used to do this thing called cross multiplying. So if you're trying to solve a proportion, you multiply along the diagonals, okay? So the diagonals being like here and here. Now for me, the variable, I always multiply the diagonal that has the variable first. That's just my preference, but you can do whatever you want. So I'm going to get B times sine of 20. And that's going to equal 4 times sine of 80. Okay? Well, I want to get the B alone. Whoops. I want to get the b alone, so I need to undo the multiplication of b and sine of 20 degrees. Sine of 20 degrees is just some number. So we divide both sides by sine of 20 degrees. Whoa, where did I go? There we go. Well, sine of 20 divided by itself is just 1, so those divide out to be 1. 1 times b is b. And I just need to go to my calculator and type in 4 times sine of 80 divided by sine of 20. So let's go to the calculator. It is going to be a lot of bouncing back and forth, which I know can be a little bit annoying, but we use what we got. So we go alpha y equals, and I need 4 times sine of 80. If you have not checked, make sure you're in degrees. I know I'm in degrees, but double check for yourself. And then we're going to divide that by sine of 20. And let's round, does it say? It doesn't specify, so let's just go 1 decimal place here. All right. Oh, don't do that to me. I should have warned you about this. This is kind of the downside to doing this. Sometimes it'll give you a fraction. But you can just divide the numerator by the denominator, and we get 11.5. If we do 1 decimal place, we get 11.51 or 11.5. Okay. So 11.5 is the length of side B. Okay. So we're going to say B is 11.5. Okay. Well, that's great. I now have the length of A, the length of B. I have all 3 angle measures. I still need to find the length of C. So we're going to do the same thing, but this time we're going to look at angle A over little a and set it equal to angle B over little c, okay, or angle C over little c, okay? The reason I'm choosing to do sine of 20 over 4 is because I know that's exact, okay? With B, I had to round my length for little b, okay? So the length for little b was rounded. So if I use this right here instead, I'm going to have a rounded value inside another value. So I'm going to be rounding twice. And so we're going to get kind of like that compounded rounding error. So I try to do exact values when I can, okay? So with that said, we're going to take sine of 20 degrees over 4, set it equal to sine of 80 degrees over c. And hopefully some of you are like, what? This looks exactly the same. And it is. Okay? But we're going to do this just to prove a point. So we're going to cross multiply, cross multiply. We're going to get c times sine of 20 degrees equals 4 times sine of 80 degrees. We want to get c alone, so we're going to divide both sides by sine of 20. And we get c equals 4 times sine of 80 divided by sine of 20. And hopefully that looks really familiar because it's exactly what we got right here. And so at home, can anybody tell me why this is the case? Hopefully you're like, well, we had an isosceles triangle, right? And so we know that if we have 2 angles that are the same, we have to have 2 sides that are the same as well. Well, we know side A is 4. We know side B is not 4. Okay, so we know one of the other side, C, has to either be 11.5 or 4. Well, it doesn't have a matching angle to A, so it has to be 11.5. So we would say C is also 11.5. And so you didn't really have to do this work. So you didn't actually have to do any of this. If you could have like acknowledged that you had an isosceles triangle, you knew that this had to be the length of side C, okay? Now, if you forget, you can do the work. You're just going to get the same answer, okay? Now, let's repeat this process, but we're going to look at a new situation. So we have an angle, and a side. Let's go ahead and draw our triangle. So remember, regardless, I always draw my triangles like this. A, B, C. C is 2. B is unknown, A is unknown, big B is 45 degrees, C is 30 degrees, A we don't know yet, okay? So I always draw my triangles the same way, okay? So just keep in mind they're not always going to be drawn to scale. In fact, they're rarely going to be drawn to scale, okay? Now let's see, we know 2 angles, so we can easily find the third angle. So angle A is going to be 180 degrees minus 45 minus 30. So that's going to be 180 minus 75. So A is going to be 105 degrees. And like right off the bat, you can tell this is certainly not drawn to scale. Okay, this would be an obtuse triangle. So 105 degrees. Okay, so we have our angles. We now need to find the lengths of the sides. So what I do at this point is I fill in the law of sines. So I know it's sine of A, which we now have as 105 degrees over little a, equals sine of B, which is 45 degrees over little b, which equals sine of C, which is 30 degrees over little c, which we know is 2. Okay, so luckily we have one full ratio, and if we have one full ratio, it's really not that bad. Okay, so let's go ahead and use this ratio involving big C and little c, and we're going to use it along with the ratio for big B and little b to solve for the length of side B. Okay, so we get sine of 45 degrees over little b equals sine of 30 degrees over 2. We're going to cross multiply just like we did in the last example. So we're going to get 2 times, well, I like to put my b on the left. So we're going to get b times sine of 30 equals 2 times sine of 45. Remember, sine of 30 is just a number, so I want to divide both sides by sine of 30. That tells me that b is equal to 2 times sine of 45 degrees all over sine of 30 degrees. Okay, so let's go to the calculator. I hope it doesn't give us that stupid answer again if we do the fraction where it doesn't reduce it or it doesn't make it a decimal for us. It tries to reduce it. So let's see, we had 2 times sine of, was it 45? Yeah, sine of 45 divide, oh, was it? I honestly don't remember what I had. Does this annoy you when I do this? Sine, so sine of 42 times sine of 45 divided by sine of 30. I feel like I said sine of 20. Okay, so we have 2 times sine of 45 divided by sine of 30. And we're going to round like one decimal place again. So we get 2.8. Okay, so 2.8 is the length of side B. Okay, so we can say B is approximately 2.8. All right, now let's do the same thing, but this time we're going to use the ratio that we know for sure that doesn't have any rounding in it. So we're going to stick with sine of 30 over 2, and we're going to use it to figure out the length of little a. Again, I try not to use rounded values if I can help it. So I would rather not use this ratio right here because little b has been rounded. And so again, it just kind of compounds that round off error. Okay, so I'm going to try to always use exact values when I can. Okay, so we get sine of 105 degrees over little a equals sine of 30 degrees over 2. We cross multiply and I get a times sine of 30 degrees equals 2 times sine of 105 degrees. And I do have to do the full process because I don't have an isosceles triangle here, okay? So a is going to equal, well, I need to divide both sides by sine of 30. So I get 2 times sine of 105 degrees all over sine of 30 degrees. And let's see what we get. So we're going to go alpha y equals, and we have 2 times sine of 105 degrees divided by sine of 30 degrees. And again, we'll round like one decimal place. So we get 3.86, which is really 3.9 when we round. So we have that side A is 3.9. And we have everything we need here. So notice this, I'm going to put in red the values that we had to find. So we found that one. We know this is 2.8. We know this is 3.9. And it makes sense that length A would be the biggest because angle A is the biggest. It would make sense that length C is the smallest because angle C is the smallest. It would make sense that angle B and side B are right in the middle, okay? So keep that in mind when you solve these problems. You can kind of sort of check things out to make sure things make sense, okay? So there you have it. I think that's it for topic 2. Next up, we're going to look at that second part of case 1 where we have angle and then a side and then an angle. So we have an angle, the side in between, and then the next angle. Okay, so that'll be topic 3.